Thank you so much. Very glad to be here. Hi, everyone. It's an opportunity for me to present, first of all, some aspects of S&T, some figures, and then the activities of our group, that is the Signal Processing and Communications group of S&T. So, some figures about, first of all, the personnel. S&T stands for the Interdisciplinary Center for Security, Reliability, and Trust. We have a workforce of more than 500 people that comprise more than 65 nationalities, and more than 30% of the alumni stay in Luxembourg. Now, in terms of partnership and innovation, we have around 50% of our doctoral candidates involved on industrial projects, so we have a large collaboration with industry. We have more than 65 partners, around 65% of annual budget comes from external sources. And finally, we were able to create 6 spin-offs from our activities. Now, talking about our group that I represent, that is the Signal Processing and Communications Group. It is by far the largest group of S&T. The head of the group is Professor Simeon Hadjinotas. In terms of personnel for this year, we are around 100 people. And we perform research on non-terrestrial networks that have to do with spectrum and interference management, multi-antenna technologies, the integration of terrestrial with non-terrestrial networks related to both 5G and now the upcoming generation 6G. Also, we perform work related to artificial intelligence and related use cases, linear communications, optical inter-satellite links, quantum key distribution, and we are also involved in more areas, not only related to non-terrestrial networks, and you can find more by following our link. And we have published several of our works in renowned journals and conferences, and we have a large network of collaboration with big industry players, such as SCS from the Luxembourg ecosystem, Thales Alenia Space, Airbus, and several more, such as OHB and Deutsche Telekom, just to mention some indicative ones. And we also have some teaching activities corresponding to 2 master programs in space technology and business and cybersecurity. The integration of terrestrial with non-terrestrial networks is the main portfolio of our activities. We perform works related to the integration of these 2 ecosystems, also related to network topology optimization, spectrum management and coexistence, smart radio connection, and joint communication, sensing, and position navigation and timing, so not to rely on the commonly used GNSS, but to increase the reliability by leveraging also low Earth orbit satellites. And we are also proud to be the coordinators of the Horizon Europe Ether project. This is one of the first projects that perform work related to the unification of the 2 works, of the terrestrial and the non-terrestrial, and we perform research with respect to low-level technological enablers, such as direct-to-device handheld access, which is a hot topic, handovers from terrestrial to non-terrestrial networks, predictive analytics, but also higher-level enablers that have to do with the management and orchestration of the complete, let's say, large-scale network. Our research lines are divided into 3 categories that correspond to short-term goals, mid-term goals, and long-term goals. Regarding the short-term goals, we conduct works related to spectrum management, multi-antenna technologies, and multi-connectivity technologies that I will mention a few things later. The mid-term goals correspond to standardization, so although we are an academic entity, we are quite involved in standardization, artificial intelligence, lunar communications, and the long-term goals are related to security for space, and the main topics are optical communications and quantum. Now, a few words about our competence areas. First of all, we start with spectrum management. We all know that we are in an era of proliferation of satellites, particularly low Earth orbit satellites, for which new spectrum is allocated. So this leads to a bottleneck, and inevitably, we need to use the spectrum. And the trend now is what we will see is the reuse of the spectrum that is used for terrestrial networks to be used also for the non-terrestrial networks, particularly the ones related to low Earth orbit satellites. So we need to we need to investigate methods to avoid the corresponding interference that will arise based on the coexistence. And by doing that, we will have an improvement on the spectral efficiency, but also the reduction of the cost per bit. And the innovations that are related to our works that we bring forward are radio resource management and orchestration, spectrum coordination scheme and architectures, antenna array processing that relates to pre-coding and beforming methodologies, and general interference management strategies. And this is the timeline of several projects where we have incorporated the related innovations. The second area is related to multi-antenna technologies, where some innovations relate to beam pattern design, user clustering, power allocation methods, frequency allocation that is suitable for low power and low cost, also spacecrafts. And we provide expertise related to antenna design, optimization for the networks, VLSI design, and also we conduct hardware prototyping. Again, at the bottom, we can see a timeline of the projects where we have involved this related research. Now, going to the third area of competence, we are talking about multi-connectivity technologies. So the idea here is to combine resources from multiple satellites. And why to do that? Because the trend is to have miniaturization of the satellites, not to have the past monolithic satellites that are equipped with very large antennas. This induces high launching costs. So we would like to go into miniaturization when we see there are many ventures that promote CubeSats, for instance. So we need to have some investigation on how we can leverage these multiple satellites as if we had a monolithic satellite. And the expertise related to this domain that we will bring forward is related to synchronization among satellites, antenna design, optimization approaches, the ground segment modem design, and also, again, hardware prototyping. The fourth area of competence is related to 5G, 6G standardization. I mentioned before that we're an academic entity, so someone would find strange maybe that we are involved. We are interested in standardization activities, but in reality, we conduct this, we help, we assist some big industrial partners such as SES, Post, to experiment some technologies that are of interest to them, and they are included in 5G related standards, but they are also to be seen in the 6G standard. So for 5G, the NTN SATCOM standardization was kicked off with the release 17 in December 2019, and multiple demonstrations contributed to the study feasibility of having the non-terrestrial segment into 5G standard. And the system radio network NTN improvements are studied and are incorporated to the 5G, but also 6G 3GPP releases. So 18, 19, and the 20 plus that is forthcoming. And the innovations that we are bringing forward, first of all, we have the joint SCS S&T lab to perform 5G new radio demos, Doppler round-trip time with NTN adaptations, the GNSS independent free positioning that I mentioned before to increase the reliability by leveraging low Earth orbit satellites, predictive handovers related to LEO constellations, support also for 5G multicast and broadcast applications, seamless cross-border roaming, and also the hot topic, direct-to-handheld device access and direct-to-vehicle connectivity. Proceeding with the area of artificial intelligence is everywhere, and the satellite communications couldn't be an exception, of course. So what artificial intelligence, machine learning more specifically, can help with is to overcome the traditional signal processing techniques in terms of both performance and power efficiency. Also, we conduct research related to new artificial intelligence chipsets that enable the use of machine learning on board the satellites that are quite constrained in terms of resources. For this, we investigate neuromorphic computing with industrial partners. That is also a very hot topic. And the innovations that we have brought forward is the creation of the CubeSat lab in the context of the Project SPICE, the acceleration of onboard radio resource management and adaptive beamforming, power-efficient spectrum monitoring, beamforming, and radio resource management via the neuromorphic computing that I mentioned before, intelligent hardware impairment precompensation, and finally, enhancement of satellite terminals via the neural networks. The last area of competence is the optical and quantum communications. In terms of relevance, we know that free space optics are the well-established option for intersatellite links, and it is the only option for the quantum space segment. The quantum key distribution is a near-term valorization of the technologies, but long-term we target the quantum internet, that many things have been mentioned up until now. And the local ecosystem is already heavily investigating in this area with the actions of SCS, the RHCA, and POST from Luxembourg, and there is, of course, a very strong political backing for that. And the innovations that we bring forward is the high-speed coherent free space optics, the network management of the intersatellite links enabled large low Earth orbit constellations, the inter-domain orchestration of the integrated terrestrial satellite QJD system, and for that we have the Luxia project where these are investigated, so there is the creation of the testbed with SCS, and finally some advanced concepts for quantum Ethernet. So I believe I have been quite brief, but comprehensive related to our activities, so thank you very much for watching.
Thank you. Thank you very much. A round of applause, please. Thank you.
Thanks so much.